Hello everyone and welcome. This one is a calculator from around 1970, the Philips model P252. It is one of the first electronic calculators, and compared to the mechanical machines used before, it was silent, fast and easy to use. But the weight is still very light, 15 kilograms. The cost was 4,790 Deutschmark, that is around $10,000 or euro nowadays. The Philips P252 of 1970, it's similar to the Olivetti 27-2 from 1967. Both are big calculators with similar functions, basic operations, memory and some special function. But if we look at the inside, it's very different. The Olivetti 27-2 is almost completely mechanic, while the Philips P252 from 1970 has already a lot of electronic inside. There are only 3 years between them, and it seems a century has passed. One of the main particularities is the dot matrix printer it used to print the results. The dot matrix printing is a technology conceived already in 1925 by Rudolf L. with his L. Schreiber. But only in 1968, Oki company introduced the first dot matrix printer. So this one could be one of the first dot matrix printer in commercial use. Printing speed was 90 characters per second. It's not bad. The printing head consists of 7 electromagnetic drivers. Each driver moves a thin steel wire inside a small tube. When it is needed to print a dot, the driver pushes the steel pin forward. At the end of the 7 wires, there is a small plastic block where the wires are aligned vertically. So to print a number, it was printed 1 dot at a time. 7 lines of dots disposed in 2 to 5 columns form a number. In the 1980s and 1990s, this printing system was the leading system in the printers. The P252 was a very powerful calculator. Besides the 4 standard operations, it calculated also square roots, percentage, multiplication with a constant, and had 2 independent memories to store and retrieve numbers at any moment during a calculation. These are the buttons to manage the numbers in the memory: adding, subtracting, clearing, etc. This wheel is the selector of the decimals. Let's see the inside. There are some electronic boards all around. You see that there is already a lot of electronics. In the back there is the power supply system with the transformer and the fan. This is the circuit board that handles the power supply to drive the printhead. You can see various types of transistors. Electrical resistors with color codes for their identification. Diodes, electrical capacitors, Let's remove the electronic board. Here there is the print synchronization wheel, this one. On the other side there is the electronic board dealing with the memory. It's here that the calculator keeps in memory the numbers. It uses the magnetic core memory that was the predominant form of computers' RAM memory from 1955 to 1975. Core memory uses these teeny magnetic rings called toroid. Each core represents one bit of information. The cores can be magnetized in two different ways, so giving a binary value of 1 or 0. Core memories required extremely careful manufacture, almost always carried out by hand. If you think it's obsolete, look at the Olivetti Logos 27 of 3 years before. The numbers were kept in memory with these wheels, gears and shafts. Between the late 1960s and early 1970s, the first semiconductor memory chips began to be commercialized, making the end of the core memory. Let's take it off. Then there is this one, the arithmetic unit. Is the unit that performs the arithmetic operation and data manipulation work, so addition, subtraction, etc. But also read data from memory, receive the data and the commands from the control unit, executes the logical operation. Could be has been repaired. Do you see the welding is different? Or it could be that the factory, when they checked the weld, they thought it needed to be re-welded. Then this one is the control unit, full of integrated circuits. Its role is to direct and coordinate the operations of all other parts of the device, interpreting instructions and generating the control signals necessary for their execution. And this is the output unit. It received the data from the control unit. It is responsible for coordinating electronic signals from hardware devices, in this case, for example, the keyboard or the printer. And in the end, the square root unit. There is an entire board dedicated to the square roots. Under it there is the bus of the board, similar to the one on the current computers. Of course, electronic circuit board have improved a lot since then, and we can carry in our pockets very small devices thousands of times more powerful. Anyway, if you look at where we started, you realize how much progress has been done, and perhaps how much more there is still to be done. Probably in 70 years, our descendants will look at our modern devices and consider them ridiculous and unusable. But it's a progress. Have a nice day.